Okay, this is going to be a tutorial on how you draw orbital diagrams and electron configuration. Up here, what you're seeing is the final product. I'm going to teach you how you get here. So this part right here, the 1s2, 2s2, and so on, the numbers only, this is electron configuration. Where all these boxes are and the arrows are, this is called orbital diagram. When you see boxes or when you hear the word diagram, I'm sure you think of a picture. So just know that the pictures are called orbital diagrams. We'll start off with this worksheet right here. You're also going to need a periodic table. Before we can learn how to draw orbital diagrams, there are a couple of rules. So as you can see here, it's called the off-bow principle, Pauli exclusion principle, and Hund's rule. For the off-bow principle, it states you have to fill the lowest energy level first, and all that's stating is you pretty much have to start at number 1, and you go in numerical order. You have this in your notes. You're not allowed to use this on your exam, but this is a good visual to practice on. So you have to start at 1, the top of the periodic chart, and you go in order. For example, 1s2, 2s2, 2p6, 3s2. You go in order. You cannot start at 5s2, then jump to 3d, and then go to 2. Okay, so that's what the off-bow principle means. Secondly, the Pauli exclusion principle states there's only 2 arrows per box, and they have to spin in opposite direction. So there's a good example right here. There's only 2 arrows per box, and they're going in opposite direction. Okay, that's a rule you have to follow. It's Pauli's exclusion. The last rule we have is called Hund's rule. Every box must have at least 1 arrow before you can double up. Example is 5A below, down at the bottom of the page, and we'll get to that in just a minute. Let me zoom in so you could write this down. You can go ahead and pause it and write your definitions down. An example of the Hund's rule, which states you have to put at least 1 arrow in each box before you can come back and put the other arrows in. So you would go 1, 2, 3, 4, 5, then you can come back. There's not a 5th one because it stops at 4. But this is a good example not to do 1, 2, 3, 4. Don't double up first. You have to put 1 per box all the way through, then you can come back and double up. Okay, the question for number 2, how does the figure to the right illustrate Hund's rule? According to Hund, every box must have at least 1 arrow, and that's exactly what happened in this 2P. See, for 2P, they did 1, 2, 3, and came back to double up. That's the correct way to do it. The incorrect way would have been to put 1, 2, 1, 2. Okay? Fill up each box one at a time, and that's what they did in 2P diagram. Number 3, how does the figure above illustrate the Pauli exclusion principle? According to Pauli, there's 2 arrows per box. That's exactly what they did. 2 arrows per box in opposite direction. There's not 2 arrows in these 2 last boxes because there were not enough electrons. Whatever element they were getting to, it stopped right there. So in the last P level, there's only 4. 1, 2, 3, 4. So let's get some practice with the rules. If you look down at 5A, state yes or no whether each of the following are following the rules. So 5A, is it following the rules? Your answer would be no. Because right here, they doubled up right away without going through each box. So you need to put 1 arrow per box until you go all the way through. Okay, and if you look at B, is B following the rules? No. B is not following the rules. The arrows need to go in opposite directions. And you can feel free to pause it at any time to write down the answers. For 5C, is it following the rules? And the answer for 5C is yes. Now let's get some practice in for 6, okay? The arrows are the orbital diagrams. They did not enclose the boxes, and that's fine. When we do orbital diagrams, we enclose the box like that. So the first thing you want to start with is identifying what element is. If you're trying to find out what element it is, all you need to do is count the arrows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's 15 electrons. So now you would go to your periodic table. So go ahead and grab your periodic table and look around for atomic number 15. Here is atomic number 15. This element is phosphorus. So the orbital diagram is already done for us, but it's up to us to figure out the electron configuration. Let's organize your periodic table if you have not already done so. Something that you need to have written on your periodic table is that these first two boxes are S. You see right? S. Okay, if you take a look. So these first two boxes are the S energy level. And the maximum electrons S can hold is 2. And if you take a look, the 2 represents how many electrons or how many boxes there are. 1, 2. 1, 2, 1, 2. Okay, in the very center region, this is the D block. And it's all the transitional metals. And the maximum arrows that can go in the D box is going to be 10. If you pay attention and you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 10 boxes. Something you do need to make a note of, although this is 4, so you can see they're all labeled, that's 4. Once you get to the D block, it starts at 3D. Okay, so you will be going from 4S to 3D, and we'll practice with that. After 3D is 4D, and 5D, and 6D. Once you go back over to the P's, okay, for example, this is 4S because it says 4 there, 4S, only the D's drop down to 3, and then when you come over to, right, starting here, is the P block, and you would go back to 4P. So only the D's are off 1 letter. So this goes back to normal 4P. From here to here is the P block, and the maximum is 6. Let me show you again. Okay, from here to here, this is the P block, and the maximum it can hold is 6. 1, 2, 3, 4, 5, 6. Include neon. That's the P block. And those are just energy levels. So back to our practice worksheet. We'll start off using our notes that help. So it's phosphorus. That's 1, 2, 3, and 2 down. 1, 2, 3, and 2 down. Okay, so phosphorus is right here. So what electron configuration is we are working our way down the periodic table to the element we need. For this problem, we only need to get here. Sometimes you'll need to get all the way down to this element or this element. You will always start at 1. So I'm going to work this with you. So I'm trying to get to here where phosphorus is. So it's 1s2. Why don't I use 1s3 or 1s4? And that's because the maximum electrons that can go with the S energy level is 2. So 1s2. And you go all the way across. There's nothing else over here. They move the helium over there just to make it easier. After you go across your first energy level, you drop down to 2. 2s2, because that is the maximum S's can hold. You keep going across, and there's 2p6. Okay, why not 2p2 or 2p4? Well, because I need to keep going, because again, I'm trying to get down here to 3p3. So I need to keep working my way down the periodic table. So 2p6. Now I go down to the next energy level, 3s2. I trace my finger, and the final one is 3p3. Okay, I don't need to go all the way to the end because phosphorus is there. Now to write that down on your worksheet, you're going 1s2, 2s2, 2p6, 3s2, and 3p3. Okay, and that's why there's only 3 arrows in this last p block, because it stopped early. It does not need to go all the way to 6. If it stopped at 3p6, it would be a completely different element. It would be over here, which on your periodic table is going to be neon. So you stop wherever your element is. If you want to double check to see if your answer is correct, all these little numbers should add up to 15, and it does. So that's another way to double check if your work is correct. Add up all the little numbers, and it will always add up to the atomic number. Let's go ahead and try the next one. Okay, so step 1, count the arrows to figure out what atomic number this is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 electrons. What we've learned so far is that's going to be the atomic number, which is Na. We're not going to use our cheat sheet this time. We're going to use our periodic table because this is what you're going to be using on the exam. So I'm going to Na. Na is right here. Okay, so I'm going to work my way all the way down until I get right here. So it's 1s2. Okay, S's can only go up to 2. Let me get my paper. Okay, so 1s2, and then that takes me down to the next energy level right here where it says 2. 2s2, because I'm trying to get here. So that takes me across 2s2. I follow my finger. 2, this is the p block now. 2p6, because I go all the way through. 2p6, that takes me all the way through, and then I drop down to 3, and it's the very first one, so I don't need to put 3s2. I only need 3s1. And this is called electron configuration. Okay, now we're going to practice the orbital diagrams. We'll drop down here for N, and then I'm going to look at my periodic table. For the atomic number of N is 7. So it wants electron configuration and orbital diagram. I always do electron configuration first. 1s2 takes me all the way across. I'm going right there. 2s2, and then 3p1, 2, 3. 3p3. The S boxes can only hold 2 electrons, so it's just one box. The P boxes have a maximum of 6. Okay, the S boxes can only hold 2, so you can go ahead and put 1 box. But for P, it can hold 6 total, so you put 3 boxes because it's always 2 arrows per box. And for the P, I only need to go to 3. I'm not filling it up. So according to the rule, I need to do one at a time. And that's how you do electron configuration. And this is the orbitals. Let's do it again for oxygen. Oxygen is atomic number 8. So I'm going to look at my periodic chart. It's right here. Zoom out. Oxygen is right here, number 8. You can find it on your own periodic table. You're always going to start at 1s2. Go ahead and just write 1s2. That takes me across. Then I get to the second energy level. It's 2s2. I trace my finger. I'm still in row 2, but now I'm in the P block. 2p, 1, 2, 3, 4. 2p4. Now I'm going to do the orbital diagrams. Again, P's can hold a maximum of 6, therefore you need 3 boxes because it's 2 arrows per box. So my S is filled, but for my P box, only 4 filled. 1, 2, 3, 4. And that's the orbital diagram. I'm going to pause it there. You go ahead and try the other two on your own.